Welcome to a video on probability with dependent events. In this video, we're going to focus on using tree diagrams to create a probability distribution and then use the probability distribution to solve the problem. Let's get started. Here's our problem statement. A jar of marbles contains 3 blue marbles and 5 red marbles. We'll let B represent the event that a blue marble is selected from the jar, and let R be the event that a red marble is selected from the jar. You're going to select 2 marbles from the jar without replacing the first. Create the probability distribution for this problem. When I look at this problem, I see 2 main things. The first thing I want to take note is that I'm selecting 2 marbles from the jar. Since this is events happening in sequence, that tips me off that I'm probably going to want to use the AND rule for probability, which is also known as the multiplication rule. The other thing I want to take note of is that I'm doing this without replacement. Once the first marble leaves the jar, it's not going to be replaced. This tells me that we're going to be looking at dependent events. Before we get started on this problem, let's just review the definitions of dependent and independent events. Dependent events are where an outcome of one event is affected by the outcome of the other event. So the AND rule, or the multiplication rule for the probability for dependent events, says that if events A and B are dependent, then the probability of both A and B occurring is the probability that event A occurs times the probability that event B occurs given that A has already occurred. When you're using the multiplication rule for probability, when you go to find the probability of the second event occurring in sequence, you have to consider how the first event affected the outcome of the second. Independent events are where an outcome of one event is not affected by the outcome of the other event. In this case, the AND rule for probability for independent events allows you to just take the probability of A and B and multiply those two together. There's one more definition that I'd like to go over for this video before we go back to our problem. We're going to use a tree diagram, which is a visual tool used to show all the possible outcomes of the probability experiment and their associated probabilities. Each branch of the diagram represents a possible outcome, and the branches can be followed from left to right to show a sequence of events. Tree diagrams are especially helpful when calculating probabilities for compound events, such as when multiple items are selected or multiple steps are involved. Let's go back to our problem and I'll show you how we use a tree diagram to help us create the probability distribution. So here we have our jar of marbles. There are 5 red marbles and 3 blue marbles. So for our first pick, we could either pick a red marble or a blue marble. Now let's stop here and just think about the probability of selecting a red marble on our first try or a blue marble on our first try. So if I reach into a jar and I pull out a red marble, since there are 5 red marbles out of 8 marbles total, the probability that the first marble is red would be 5 out of 8. Now, if I want to find the probability that the first marble is blue, since there are 3 blue marbles out of 8 total marbles in the jar, the probability that the first marble is blue would be 3 out of 8. Now, once we pick that marble, it's not going back into the jar. So let me expand out our tree diagram. For our second pick, now if my first pick was red, my second pick could still be red or could be blue. And if my first pick was blue, then my second pick could still be red or could still be blue. Now let's go ahead and calculate the probability for each of these second marbles picked from the jar. Now we need to use conditional probability here. Conditional probability is we're going to have to consider what happened with the first pick when I calculate the probability of the second one. Let's do the top half of this tree. This is when the first marble we picked was red. Now, remember, since this is without replacement, let's pretend that this red marble is gone. So now there are only 4 red marbles out of a total of 7 marbles in the jar. So the probability that the second marble is red, given that the first marble is red, would be 4 out of 7. Right below that, let's find the probability that the second marble is blue, given that the first marble was red. Well, there are still 3 blue marbles in our jar out of 7 marbles total, so the probability the second marble is blue, given that the first marble is red, would be 3 out of 7. Now let's do the second half of the tree. In this case, we're going to assume that the first marble was blue. So let's just cross it off out of our jar. Remember, we're not replacing this blue marble. So there are only 2 blue marbles in the jar and 7 total marbles. So the probability that our second marble is red, given that the first one is blue, is there's 5 red marbles out of 7 total. For the last branch on our tree, we need to find the probability that the second marble is blue, given that the first marble was blue. So there are only 2 marbles left in our jar out of 7 total. So this probability would be 2/7. Now this tree is not the probability distribution, but it's going to help us create the probability distribution. A probability distribution is when we list all of the possible outcomes for an experiment and their corresponding probabilities. What we need to do is we need to list all possible outcomes for selecting 2 marbles from this jar. And the way you can figure out all of the outcomes is just to trace along the branches of the tree. So if I trace the top branch there, the first possible outcome in this experiment would be I could get 2 red marbles. The second one would be I could get a red one for the first marble and a blue one for the second. The third outcome is I could get a blue one for the first, but a red one for the second. And the final outcome would be I could get 2 blue marbles, blue on the first and blue on the second. Now let's go ahead and calculate their probabilities. Now, to find the probability of each possible outcome for this experiment, we're going to use the multiplication rule or the AND rule because these events are happening in sequence. We're picking the first one and then the second one. So the probability our first one is red, followed by the second one that's red, I need to multiply 5/8 by 4/7. This would give me 20 out of 56, or 0.3571. For the second outcome, I'm going to take the probability that the first one is red, 5/8, and I'll multiply that by the probability that the second one is blue. So we'll take 5/8 and times it by 3/7 to get 15 out of 56, or 0.2679. Now let's take the probability that the first one is blue, 3/8, and multiply it by the probability that the second one is red, 5/7. That'll give us the probability for our third scenario, which is 15 out of 56, or 0.2679. Now I'll pause here to note that these 2 events, red then blue, or blue then red, have the exact same probability. However, they both need to be listed as different outcomes in the probability distribution because the order in which red then blue came up are different. So they are considered 2 different outcomes in the probability distribution. And finally, let's find the probability we get blue and then blue by taking the probability the first one is blue, 3/8, and multiplying it by the probability the second one is blue, which is 2/7. That would give us 5 out of 56, or 0.1071. Now this on the lower right-hand side is our probability distribution. A good way to check to make sure that you have included all of the possible outcomes is to add up all of the probabilities in your probability distribution. These should always add up to 1 because it represents 100% of what could occur in the experiment. Now let's put our probability distribution to use by looking at some problems. Let's find the probability you select 2 red marbles in a row. Once we have the probability distribution, it's done all of the heavy lifting for us. So all I need to do is find the scenario that fit this problem. For this one, the probability we select 2 red marbles in the row, that's the first one. So the probability we get red is 0.3571. What's the probability you select 2 blue marbles in a row? Well, that one is also in our probability distribution. It's the last one. So the probability we get blue then blue is 0.1071. Once again, we've already done the hard work by creating the probability distribution. Now let's take a look at this problem. What's the probability you select 1 red and 1 blue marble? Order doesn't matter. Now this one we have to be careful because order doesn't matter. There are 2 scenarios that fit this problem. We could get red and then a blue one, or a blue, then a red one. So to solve this problem, we need to find the probability that we get red, blue, or blue then red. Now, or in probability usually means addition, so we need to add up these 2 probabilities. So we need to take 0.2679 and add to it 0.2679. That gives us 0.5358. What's the probability that you do not select a red marble? So if I go over to my probability distribution, I want to look at the outcomes where I do not select a red marble. So the first one is out, that has 2 red ones. The second one is out, that has 1 red. The third one's out, it also has a red. So it turns out that this one is the same as picking 2 blue marbles. So the probability of no red is the same as the probability they're both blue, which is 0.1071. And finally, what's the probability that you select at least 1 red marble? Now there's actually 2 ways to solve this problem. So the first way is you can think, well, which scenarios have at least 1 red marble? Well, in this case, the first one would fit that description because it has 2 reds. That's at least one of the marbles is red. The second one works because it contains at least 1 red marble. And the third one works as well. So the probability of at least 1 red would be the same as the probability they're both red, or red then blue, or blue then red. Or in probability is addition. So I would add up those 3 probabilities. So 0.3571 plus 0.2679 plus 0.2679, and that would give me 0.8929. The other way you can solve this is by using the complement rule. And usually whenever you hear at least in probability, that's usually a good tip to consider the complementary rule. The complementary rule is when we consider what this is not. So at least 1 red is not both blue. So the last one down there where they're both blue is the complementary event. So the probability of at least 1 red is equal to 1 minus the probability they're both blue. That's the complementary rule. So this would be 1 minus 0.1071, which is still 0.8929. That's it for this video. Thanks for watching.